one of the superpowers of rollups is that you can customize the execution environment. Whereas in a monolithic world, let's say I have some EIP that I've been trying to push for the Ethereum L1 to adopt for the longest time, and it's going to add some functionality to the EVM that's going to enable my application. In a monolithic chain, I have to wait and kind of lobby, and it's like a political sort of like battle, and it's extremely slow. In the rollup world, there is none of that.
Hi, everyone. Welcome to Unchained, your no-hype resource for all things crypto. I'm your host, Laura Shin, author of The Cryptopians. I started covering crypto 8 years ago, and as a senior editor at Forbes, was the first mainstream media reporter to cover cryptocurrency full-time. This is the February 20th, 2024 episode of Unchained. Polkadot is a leading Layer 0 blockchain with over 2,000 developers, and the Polkadot 2.0 upgrade will be a massive accelerator for the ecosystem, making it faster, more secure, and adaptable. Perfect for GameFi and DeFi to build, grow, and scale. Join the community at polkadot.network/ecosystem/community. Streamline your DeFi with Vaultcraft, the ultimate on-chain toolkit for deploying custom automated DeFi products on any EVM chain. Join Vaultcraft's referral program, unite with the community, and supercharge your crypto. Details on vaultcraft.io. Today's topic is Celestia and modular blockchains, and here to discuss are Nick White and Mustafa Al-Bassam. Welcome, Nick and Mustafa.
Hey, Laura.
Good to be here.
So Celestia launched on mainnet back in October to much fanfare, and it's known as a data availability layer, and it takes a modular approach to blockchains. We've covered this a little bit on the podcast before, not a ton. So Mustafa, Celestia started with you with a project you were working on called Lazy Ledger. Tell us how you came up with this idea to create what is now finally morphed into Celestia.
Sure. So this was when I was doing a PhD in blockchain scaling in 2016, 2019. And I was just trying to think about a lot of different ways to scale blockchains, specifically layer one scaling. How do we scale the base layer of a blockchain? And one of the early research proposals I worked on was sharding. And this was back in about 5 years ago. The Ethereum 2.0 roadmap kind of revolved around sharding. And it was like you have 1,024 shards, and it was very complicated. And as part of that, I created, with my co-authors, one of the first papers on how to do sharding called Chainspace. And that was later spun out into a project that was acqui-hired by Facebook. But I didn't join Facebook, and instead I kind of focused more on my PhD, and I started thinking about, how can we fundamentally scale the base layer? And I started thinking about trying to unpick the components of the blockchain and trying to think from first principles and trying to unlearn everything I learned. And let's say if we created a blockchain from scratch, fundamentally, what is a blockchain and what is the simplest blockchain we can create? And that's where Lazy Ledger kind of started out. It's the answer to the idea is what is the simplest blockchain you can make that is useful for developers, that is as minimal as possible, and still make it useful to deploy applications on top of that. And that's kind of where Lazy Ledger started. And it's basically just a blockchain that only does consensus and data availability. It does not have smart contracts. It does not have execution or anything fancy. It's just a very simple blockchain where developers can post data onto it. And it turns out that is fundamentally what a blockchain does. And it's an extremely useful primitive to people building things like rollups. And that makes it's extremely useful to scale rollups and other layer 2 technologies.
And when you were trying to do that, were there particular problems you were seeing in the blockchains at that time in 2019 that you felt like this vision could kind of solve for?
Yeah, so this was back in the day before rollups even existed. And when I was focusing on sharding, the missing piece of the puzzle to sharding was this problem called the data availability problem. And it's the same problem that rollups have today. But the idea is that if you have 1,000 shards, which the Ethereum roadmap had before, how can each shard make sure that each other shard is being honest? And to do that, for each shard to make sure each other shard is being honest, it needs to make sure that all the data behind each shard was made available and published to the internet. And so this was a really hard problem at the time. How can we make sure that all the data on a chain was actually published without actually having to download all that data yourself? And that's where this idea of data availability proofs and data availability sampling came from. And that was kind of like the missing piece of the puzzle at the time to the Ethereum 2.0 roadmap. But once that puzzle was kind of figured out, I kind of realized, well, this is actually, this final piece of the puzzle is actually the core component of what a blockchain really does. A blockchain is fundamentally just a data publication layer. It's basically a data availability engine. And Lazy Ledger was the idea to just do only that and scale that extremely well. And it turns out that if you just do that and scale that extremely well, you can build any kind of application on top of it using rollups or layer twos. Because rollups are basically blockchains in themselves that use another blockchain for data availability.
Yeah. And so what this ends up doing is kind of, take this original vision of a blockchain where all the different functions all happen on one layer and sort of separate it out into pieces. So this is how we have this idea now of modular blockchains. So Nick, can you just talk a little bit about that vision for modular blockchains? Like what parts end up being modular and, what are, the different parts of a modular stack?
Sure. So as Mustafa started to explain, the original vision for blockchains, starting from Bitcoin and Ethereum and even Solana, most of the layer one chains that people know of today, followed a monolithic design, meaning that they do all of the core functions of a blockchain within one protocol. But then, as Mustafa started to think about things more fundamentally and from first principles, distilling down those functions, he realized that there's no reason why they all need to be coupled together. And in fact, you get these superpowers when you start to decouple them and do them as separate protocols. And so the three main functions are consensus, which is the ordering of data. So, if we're all in sharing a blockchain, we need to know and agree on what is the order of events or the order of transactions. If the order is mixed up, then we're not seeing the same things. The second thing is data availability, which is a confusing term, but it's data publication, essentially. It's about being able to prove to someone else that the data behind those transactions has been released and is public information that anyone can download and see. So data availability kind of provides this ability to audit the chain and see what's actually happening. And then the last one is the one that people are probably the most familiar with, which is execution. And execution is essentially where smart contracts and all the business logic and the applications for these blockchains lives. And that's where the transactions actually get interpreted and then verified into some output state. And so those are the three main layers. And Celestia focuses on consensus and data availability. And then you have rollups and layer two technologies that focus on the execution part. And so those two things are kind of the perfect complements of each other. So Celestia focuses on scaling the base layer of just consensus and data availability. And by focusing only on data availability and consensus, it can be way more scalable than a standard monolithic L1 that has to do everything all wrapped up into one package. And also likewise for these execution layers, these rollups and L2s, they just focus on that one thing and they can be really, really scalable and also be more customizable. So one of the advantages of modular blockchains, aside from what I just mentioned, is that you open up the stack for more innovation from the developer. So rather than being locked into the EVM or the SVM or any particular execution environment with a built-in execution layer in a monolithic chain, in a modular chain like Celestia, it's totally expressive and flexible because the developer can choose to run EVM or Solana VM or Cosmos SDK or Wasm, anything that they any kind of execution environment that is best for their application. And they can even customize it and build something that no one's thought of before. So modular blockchains really are a step function change in the history of blockchain architecture.
Something that's so interesting to me is we're coming from this world where pretty much most things have been monolithic or at least started that way, even if some of them are morphing into something else. And yet here you guys are, you're kind of fully on board with this modular vision. And I've even heard you say, Nick, that you believe in a world of 10,000 or more rollups. So why is that? Like, why do you think that makes so much sense? Or why do you think that's the future when, so far mostly what we've had is like something different?
Yeah, so I mean, I think the 10,000 rollup endgame is very interesting because it's very controversial to many people. In some way, it's kind of like the opposite of Solana's endgame, where you only have like one single chain. But I think the way that I see it is kind of very similar to the evolution of Web 2. Like if you look at the history of Web 2, And I'm not saying that analogy by reasoning is good, but I think it's kind of like an interesting piece of history. Like when the web was first created, the only way to create a website is if you had a physical server somewhere. Like you had in your university or in a data center, you need to own a physical machine. And that was kind of like similar to the Bitcoin days, where if to create a new blockchain or to create a new decentralized application, you need your own blockchain. Like you had Bitcoin was just only for one application, and then you had Namecoin, Litecoin, Dogecoin. It was like a different blockchain for each application. But then Ethereum came around, and then Ethereum kind of revolutionized it, because the idea of Ethereum was, instead of having a different blockchain for every single application, let's create a general purpose blockchain with a general purpose smart contract environment. And the Web2 analogy to that is kind of very similar to shared web hosting providers. Like back in the day, before you had AWS or DigitalOcean, you could like go on like a service provider like GeoCities or DreamHost or Bluehost, and you could upload the code for your site to those services, and your website would share the same server as many other websites. But the limitations of that is that you had to create your website in whatever programming language that server supported, which was like at the time PHP or Perl, and that's very similar to Ethereum. And also, you have to share resources with those other websites. That's very similar to the idea of Ethereum or the world computer model. You have to create your smart contract in the Ethereum virtual machine, your Solidity, and then upload your smart contract to this world computer and you're sharing the same smart contract as everyone else. But maybe not every single use case needs to share the same execution environment or the same computer as every other decentralized application. And that's what we're seeing recently with the proliferation of people creating their own custom roll-up chains and blockchains. And this was the kind of like the original vision of Cosmos. It's like scaling, anyone can create their own Cosmos chain, and every application has its own chain. But again, the problem with that is that there's a lot of overhead to creating your own blockchain. So the idea is that if you look at the Web2 analogy, you had the cloud, the creation of virtual machines, and the cloud was a big moment that revolutionized Web2, because for the first time in history, any developer within seconds could have access to their own virtual machine that had the same that give you the same advantages as having your own physical hardware, but without the disadvantages of having to maintain and own that physical hardware. Because developers had access to their own execution environment, they could install whatever software they wanted, and they could customize it however they wanted. And people were able to play around with new programming languages like Golang, Rust, and so on and so forth, that might not have been as easily possible before if people were limited to the same shared hosting environments. And that's very similar to what we're seeing with roll-up technology, because roll-ups, what they fundamentally allow you to do, they allow you to create your own blockchain, but without the overhead of having to maintain your own proof-of-stake network. So like right now, today, you can go, there's roll-up as a service providers, like Conduit and Caldera and Dimension. You could go on these providers today, fill out a form, and within seconds, you can have your own roll-up chain deployed immediately. And that's kind of extremely powerful, because that allows developers to have it's the same importance as when the cloud came to Web2. It allows developers to have their own fully customized chain, and they're no longer limited to the same limitations as they were limited before as EVM was. So, for example, you've got like gaming providers that have created. There's a project that has managed to embed like entire game engines in the EVM by modifying the EVM. So there's just like things that you fundamentally can't economically do on chain as easy as you can do with your own custom EVM execution environment. And another advantage is that it's inherently scaling, because not every application needs to share the same gas resources as every other application. Like if you're running your own rollup, you have your own execution. You're not sharing execution resources with everyone else. So if one application gets very busy, that doesn't necessarily need to affect other applications.
Oh, wow. Yeah. Just if I think back to, like 2017, 2018, then it's very obvious that this has advantages because, or even like later on with the whole, so 2017, 2018, I was thinking about the ICOs, how they just kind of pushed out every other use case during those periods. And then I guess would be same for, like during the NFT periods where everyone was trying to mint at the same time. So are there specific applications that you feel work better on a modular blockchain, or even that are possible with a modular blockchain that wouldn't be when they're having to, share those kinds of share the execution environment with other applications?
Yeah, so I think like the obvious ones are gaming and NFT chains, because I mean one of the like common criticisms of this 10,000 roll architecture is that composability becomes harder because you need to keep doing these cross chain transactions. That is a problem, but it's a problem that's being solved, and it's not an inherent problem. But there's many applications that don't need as much composability, especially like gaming chains or NFT chains. Like there's absolutely no reason why those applications need to be on the same chain or execution environment as some high volume decentralized exchange. But that being said, we do also have DeFi projects on Celestia, notably projects like Avo. I think something like 70% of all DeFi options trading volume is secured by Celestia as a data availability layer. And the reason for that is because it's just simply way cheaper than doing it on chain. As the cross chain kind of like interoperability issues and the UX becomes cleaner, I think people will kind of realize it's just better to do those things in rollups rather than doing it on chain.
I'll also add a few examples too. I think one of the superpowers of rollups is that you can customize the execution environment. Whereas in a monolithic world, let's say I have some EIP that I've been trying to push for the Ethereum L1 to adopt for the longest time, and it's going to add some functionality to the EVM that's going to enable my application. In a monolithic chain, I have to wait and like kind of lobby, and it's like a political sort of like battle, and it's extremely slow. In the rollup world, there is none of that. You can take the EVM, fork it, add in custom opcodes or functionality, and then just launch it as a rollup, and you have that functionality out of the box. So a couple examples that are really powerful are Manta has built a EVM chain that has custom opcodes for verifying ZK circuits, and that makes it really cheap for them to do things that are like have privacy or native randomness in the protocol. And that's really powerful for various games or applications. Like they have an application called ZK Hold'em, which is sort of like an on-chain a poker game. Or other uses are things like adding native account abstraction kinds of things, or new cryptographic curves that allow you to use the built-in like enclave in your mobile phone as your wallet. And so these are the kind of things that like you can't do on a monolithic chain like Ethereum, because you don't have control to that level of the stack. So there's a lot of applications like that where developers are exploring new sort of the frontier of what's possible because modular enables that.
All right, so now let's talk about Celestia and how it fits into a modular blockchain. Why don't you describe what Celestia is?
So Celestia is what we describe as a pluggable consensus and data availability layer, which means that it's basically like a very simple blockchain. All it does is it allows developers to post blobs of data to it. That's basically the only use case you can do it. You can just get arbitrary data and post it to Celestia. And Celestia's job is to make sure that data is ordered in relation to other data. So you can say, okay, this data came before that data. And to make sure that data is actually verifiably published to the entire internet. So there's no like missing data. So that's basically all it does. And it tries to scale that extremely well using a technology called data availability sampling. And the basic idea is that the way that the blocks are constructed allows light nodes or nodes without a lot of resources to gain the very high assurance guarantee that that data was actually published without needing to download all that data. And the way that works is the nodes can download a small random pieces of that block. And if they download enough random pieces, they can have a very high confidence that that all the data was published.
So an analogy to explain this is to maybe think of Celestia like a newspaper publisher, sort of. So the blocks are sort of like a new like daily publication of the newspaper. And if you're a subscriber, you receive the newspaper and you can read the headlines and see that the data's in there. But you don't have to read the whole thing to know that it's all been published. So it's not about it's not about storing data. Like storing data would be more like a library, because a lot of people think that data availability is just data storage like Filecoin or Arweave, but it's actually like publication. So it's about rollup developer comes with a blob, which would be like an article, they would pay the newspaper, say, hey, publish my blob in the news today's date of the newspaper. And then that would be included and packaged all up and then distributed to everyone who's running a node in the network. And they'd all be able to really efficiently verify it so that they don't have to read everything themselves, but they can still know that it was published to everyone else.
Yeah, and it's worth noting that publication is effectively, as I mentioned, like the core thing that a blockchain does. Fundamentally, a blockchain is just a proof of publication mechanism to publish arbitrary data. And that's once you have that, you can build anything on top of that as a layer 2 or as a rollup. So, like developers, as Nick said, you can define their own execution environments or computation environments, whether that's custom EVM or anything else, by using Celestia as the underlying kind of consensus and data availability layer.
And so when you talk about how it's just publishing but not storing, essentially it makes the data available for some time period when it's necessary. And then after that, then I guess it's stored elsewhere or something. Or I guess, is it that it's no longer available after finality on the execution layer or something like that? Like, how long is it available?
So currently, we have a CIP that proposes that it's kind of like guaranteed to be available for 30 days, which is kind of similar to EIP 4844 in Ethereum. In that proposal is 21 days, but it's not as if the data disappears after 30 days. It's more that it's pruned, but you'll still be able to download the data from kind of like archival nodes that store longer term data. So it's very likely, it's almost certain that you'll still be able to download that data, that historical data. It's just that like there's no kind of like in-protocol guarantee that it will be downloadable. Or like if you need higher assurance guarantees that you can download it in a certain amount of time, then you probably want to do some kind of like off-chain storage solution. So for example, you've got systems like Filecoin or Arweave that solve this problem, or that kind of like incentivize storage. But we provide a different, Celestia provides a different goal in storage. As Nick said, it provides publication, which is fundamentally a different thing.
So again, to like one way to think about this is like, a newspaper publisher doesn't keep the newspaper around indefinitely. They publish it, they let people take it and read it and all of that, but then they're not expected like, oh, if you ask the newspaper, hey, can you give me the newspaper that happened 10 years ago, they're not going to have it on hand. However, there are other services like libraries that actually do store every single newspaper. And you can think of those libraries as more of the storage, like the data storage protocols like Arweave or Filecoin. And storage, like data availability, is something that is critical to the safety of blockchains. Like it's critical to the security, whereas the storage and it has like much tougher trust assumptions that you have to tackle. Whereas data storage is just, you need one honest party to store the data, and it's not as important for safety. It's more about the ability for like liveness, the ability to regenerate the state of the chain. So they're very different things. But the problem is that data availability sounds a lot like data storage.
Yeah, yeah. I when I was first learning this concept, like didn't fully understand in the beginning. So you guys referenced the term data availability sampling. So talk a little bit about how that works, what it is exactly and how you make that secure.
Well, Mustafa, co-invented it, so I'll let him take this one.
Yeah, the general idea is that the goal is how can I make sure that some block or some piece of data was published to the internet without me having to download that entire block or data? Because it almost sounds impossible, right? How can I, if I have this data, if I have the hash of the data, how can I know that this data was published? And data availability sampling seeks to solve that problem. The way it works, it uses this kind of like this mathematical primitive called erasure coding. And erasure coding is a mathematical primitive used in a lot of kind of older technologies like CD-ROMs and satellite communications. If you can think of a CD-ROM, if you scratch a CD-ROM, and maybe this is more for the older audience if you remember this, but if you scratch a CD-ROM, your computer can still read the data on that CD-ROM. So how is that possible? That's possible because the data on that CD-ROM is encoded using something called erasure coding. And the way that works is like, let's say you have 1 megabyte of data, for example. What you can do is you can apply erasure coding on that data to effectively blow that 1 megabyte of data up to two megabytes, such that if you take this 2 megabytes of data, and if any half of it is missing, you can reconstruct half of it from the other half. And that's including like any half of the data, like any chunk. As long as you have half the chunks of the data, you can reconstruct the other half. So it's kind of like a way to extrapolate data or to recover data. It's kind of like a self-healing file. Like if you damage that file, it can kind of like repair itself from the remaining pieces of the data, the file. Almost like if you kind of like have a wound, your body repairs itself. So what that means is that if you apply that for a blockchain, if you apply a rage coding onto a 1 megabyte block, for example, you now have a 2 megabyte block. But what that means is that you no longer need to make sure that 100% of the data is available to make sure that it's all available. You only need to make sure that 50% of the data is available to know that it's all available. Because if you know that 50% of the data is available, then you know that you can always reconstruct the other 50% from that 50% that you know that you have. Now, so then that's a very kind of powerful piece of information that you can use to create a game where, as a user, if I know that I only need to make sure that the person who created that block or the miner that created that block is being honest, if the miner is trying to hide a piece of data, they need to hide at least half of that data. So all I need to do is make sure that half data is available. What I can do is I can download random pieces of that block, right? If I download one random piece of that block and the miner is being malicious and I landed in the part of the block that's not available and I don't get a response, then I know that block is not available. So then if I do one sample, there's a 50% chance that I know the block is available. Then you do 2 samples, it's 75%, 3 samples, 87.5%, until you get to 16 samples. Yeah, you have like a 99% guarantee. Then after 70 samples, you have a extremely high guarantee that's lower than the probability of a hardware failure. And that's effectively how it works.
Add a little more onto that. It's sort of one mental model to think about it that I find useful is like flipping a coin, where each time you sample the block, you download just a small tiny part of it and it lands heads, meaning the data is available. You get an increased confidence that the whole block is available. So if you flip heads, 16 times in a row, it's like, okay, well, the statistical odds of me flipping heads every time is really low. So therefore, it actually, all the data must be available. And what's powerful about this is that it enables the underlying chain. An underlying chain that employs data availability sampling can scale with the number of people who are sampling. So the number of users running light nodes allows the block size to increase. And so unlike standard blockchain where there's a fixed block size, data availability sampling makes the block size elastic and able to grow with demand and usage. So it's sort of like the broadband moment of Web3, where all of a sudden we have a step change in the scaling properties of blockchains that will actually, makes it feasible for us to scale to millions and hopefully in the future even billions of users and still remain trust minimized, because end users can run these sampling nodes on hardware like a smartphone that everyone has. So it makes the blockchain really scalable while still being verifiable.
Wow. And so right now, what would the size of the block be given the number of data samplers that you have? Or I don't know if I phrased that correctly, but you understand what I'm asking.
Yeah, so right now, because we only launched mainnet 3 months ago, we've started with a relatively small block size, which is 8 megabytes, which is still 20 times more than EIP 0.44. But this is to allow an early network of light nodes to kind of bootstrap itself. So in our incentivized testnet, there was 1,000 light nodes, and there's many people running light nodes on mainnet, but it's still early stages because we need more metrics. We need kind of like systematic metrics for the community to know, okay, this is how many light nodes there are on the network. Therefore, it's safe to increase the block size. Because the problem with light nodes is that they're not stable resistant. It's like anyone can run a light node. So you kind of like need to have kind of good off-chain metrics to kind of like analyze how many light nodes, how many real or how many total light nodes there are. And that's something that kind of the community is kind of building out.
So I'm sorry, when you said 1,000, that was in testnet. How many light nodes do you have now on mainnet?
There isn't like a clear metrics on that because there needs to be a crawler to kind of map out the light node network to kind of count how many light nodes there are.
Okay. And you're building that or that's being built or?
Yeah, that's being built by a team called Iger, which is kind of building a Rust node for Celestia.
Okay. Okay. So I guess it's a mystery for now. So in a moment, we'll talk a little bit more about the vision for Celestia. But first, a quick word from the sponsors who make this show possible. Polkadot is the largest Layer 0 blockchain with over 2,000 developers. And the anticipated Polkadot 2.0 upgrade will be a massive accelerator for the ecosystem. Upgrading the infrastructure with 8 times higher transaction throughput and twice as fast block times, perfectly tailored core time for the needs of every protocol, trustless bridges internally and into Ethereum, Cosmos, Near, and Binance Smart Chain, revised tokenomics, and the implementation of a token burn to reduce inflation. Perfect for GameFi and DeFi to build, grow, and scale with one of the most active crypto communities in the space. Polkadot recently announced a partnership with Mythical Games, bringing top games like NFT Rivals with over 650,000 players and 43 million transactions to pave the way for GameFi and the Polkadot ecosystem. Get your Web3 ideas to market fast with economics that work for you. Think big, build bigger with Polkadot. Join the community at polkadot.network/ecosystem/community. DeFi just got way easier with Vaultcraft, a blockchain infrastructure for building, deploying, and monetizing non-custodial yield strategies in a few clicks. Forget spending months of R&D, capital, and human resources when you can now instantly launch your crypto fund with Vaultcraft on any EVM chain. From wallets and institutional service providers to non-DeFi degens, Vaultcraft supercharges your crypto assets by enabling instant cross-chain yield strategies that you can deploy in 1 minute. Now anyone can supercharge their crypto portfolios with custom-tailored DeFi strategies. Join Vaultcraft's referral program, unite with the community, and supercharge your crypto. Details on vaultcraft.io. Back to my conversation with Nick and Mustafa. So we talked about modular blockchains. We talked about how this will allow many kind of more application-specific chains and rollups. We talked about how Celestia is providing this data availability layer. So now that this is launched, like, how do you think this will change the crypto space? Like, what new kinds of applications will be enabled, or what kinds of things will they be able to do now with Celestia?
We talked about a few of them. I think the first sort of category are applications that need a lot of block space and have a lot of really high throughput requirements. So some of the ones that Mustafa mentioned earlier are things like on-chain DeFi applications, like some of these options exchanges. They have a lot of demand for block space, right? And only Celestia can provide that because we have data availability sampling. We have the ability to increase our block space with the amount of demand and users. Other things that fall into that category to me are things like on-chain gaming, where there's just going to be a huge high volume of transactions, and they're going to need a very cheap place to post that data. And kind of related to that and building off of it are a lot of there's a huge demand in the Ethereum ecosystem to launch Ethereum L2s. And the issue is that Ethereum block space is quite limited because it is monolithic. And so there's a limited amount of sort of like data that you can post to Ethereum. And so it's quite expensive. So only the sort of like most well-funded or most like highly used ETH L2s can afford to use Ethereum as their data availability layers, those things like Optimism or Arbitrum, for example. But all these other teams that want to deploy L2s in the Ethereum ecosystem are kind of priced out. And so Celestia has come in and provided a place for them to post data that is dramatically cheaper and makes their application actually feasible. And so rather than having to pay literally millions of dollars in DA fees, they can cut that by 99%. And all of a sudden, the gas cost for users is now on par with chains like Solana. So we're making the Ethereum ecosystem competitive with a lot of these alt L1s by providing this really cheap DA. And so we're seeing a lot of demand for rollups to deploy on Celestia while still settling to Ethereum. So we're helping to sort of scale the Ethereum L2 ecosystem with this cheap modular DA.
And then part of this is something called Blob Stream and also something called Blob Space. Could not really figure out what this was in my research beforehand. I mean, I have like a definition written down, but if you could just explain how all that fits in. that would be helpful, not just for me, but for the listener.
Yeah, so I can take this one. So kind of Blockstream is effectively the way that Ethereum rollups can use Celestia for data availability. Effectively, it's like a one-way bridge between Celestia to Ethereum, but it's not a bridge for relaying assets or transferring assets. It's a bridge for basically like transferring data commitments. So the way it works is that the Celestia data commitment is relayed to Ethereum every hour or so into a smart contract. And then that basically allows Ethereum rollups to reference data on Celestia using a proof that that data was included in that Celestia data commitment. And so that basically allows people to build L2s and L3s on Ethereum that use Celestia for data availability.
Okay. And so something else that was interesting to me is, I guess in the event of a fork, Celestia would actually make it easier for the two chains to fork. Can you explain how that works?
So I think, are you referring to the concept of sovereign rollups?
I don't know. I was either listening to a podcast or I read something where it talked about how if this had been available at the time of like the DAO or, when Bitcoin did its big fork, that it would have made these contentious hard forks less contentious.
Yeah, so that goes into the topic of sovereign rollups. So it's worth explaining what is a sovereign rollup. So if you look at like traditional rollups, when rollups were kind of first popularized, rollups were originally kind of proposed as a way to scale an L1. So like rollups being an L2 to an L1. But what I kind of realized is that it's possible to just have a rollup as an independent chain in its own right. Like a rollup does not have to be an L2. Like a rollup can be like an independent blockchain, like a layer 1 chain is, but it's not a layer 2 to any other chain. It's just like an independent chain on its own right that happens to post or use another chain for data availability and consensus. But that does not make it an L2 because it does not mean that that kind of like rollup needs to have an enshrined bridge to that data availability layer. And the reason why this is interesting is because this is kind of like the original vision of Cosmos. But the idea is like you can create your own Cosmos chain, and that Cosmos chain has sovereignty because it's like an independent chain in its own right. But it has the ability to hard fork, right? Whereas like if you create a smart contract or a DAO on Ethereum, it's not really easy to hard fork that smart contract without hard forking the Ethereum chain itself. Whereas if you create your own sovereign chain, whether it's a sovereign rollup or a sovereign L1, the community of that rollup can kind of like hard fork its own chain if it wanted to. And I think the ability to hard fork is very important. Because to me, the whole point of blockchains is that they implement kind of like the rules that social consensus has decided. It's basically like an implementation of a social contract. So it's like if you're deploying a smart contract on Ethereum, you're inheriting the social consensus of Ethereum. But what if you want to have your own social kind of consensus or social layer? Because Ethereum, as you mentioned, the DAO hack, around 2017, there was this massive hack on this big contract in Ethereum called the DAO, 2016, and something like 5% of the Ethereum supply was compromised. And the Ethereum developers decided to hard fork the Ethereum chain to undo that hack. And then, if I remember correctly, there was like another hack, similar hack of like something like $100 million. I think it was parity, if I remember correctly. But they didn't hard fork in that case because it didn't constitute as big of a percent of the Ethereum supply. So then the question is like, why should only like big contracts be able to hard fork? And this is why the idea of like having your own sovereign chain can be important, because if a DAO is on a smart contract on Ethereum, then it's not sovereign because it does not have the ability to hard fork. Whereas if a DAO on its own chain has the ability to hard fork if it wanted to, and that's to me, it's an extremely important kind of like part of a blockchain, like a part of cryptocurrency is this ability for the community to hard fork, to do upgrades via hard forks.
Oh, now I get it. So it's not necessarily that the existence of Celestia would have prevented it. It's more this vision of these modular blockchains allow these app chains, and then the app chains can do their own forks that don't affect the rest of the execution environment. Is that?
Yeah, exactly.
Oh,
It's not so much the idea of Celestia itself. It's the idea of this idea of sovereign rollups. which
Mm-hmm.
we kind of like, which Celestia introduced.
And sovereign rollup is the same as like the notion of an app chain.
Yeah, it's basically. I mean, it doesn't have to be an app chain. It can be like a general purpose chain, but it's similar to a layer one. Like the same way that a layer one can hard fork, a sovereign rollup can also hard fork, because like the difference between a sovereign rollup and like let's say a traditional Ethereum rollup is that a traditional Ethereum rollup has what I call like an enshrined bridge to Ethereum. So like you can say that rollup is defined by the bridge on Ethereum. It's like it's defined by the smart contract on Ethereum. The canonical chain for that rollup is what the bridge says it is. But for a sovereign rollup, the idea is like, okay, well, what if we don't enshrine the bridge? What if we just say this is actually an independent chain on its own right, and the bridges are secondary in the same way that a layer one bridge is secondary to the layer one itself?
It's sort of like the
Ah,
difference between being like a state within the United States or under some like larger like federation or like a country versus being your own country. So like a sovereign rollup is a lot more like its own country that can do its own rules and make changes however the community decides. Whereas if you're a standard sort of settled Ethereum rollup, you're still kind of bound by Ethereum, the country that you are sort of like incorporated under.
okay. And then to continue that analogy, so since they're all sharing security, then if you are this separate country, like it's like you're part of NATO along with other countries. Is that another way to extend the analogy?
Yeah, because Celestia, yeah, I guess in like typically if you're your own independent country, then you have to have your own military, you have to do all these like provide your own infrastructure essentially. But in and that would be sort of more like the Cosmos model is you have to bootstrap your own chain, have your own proof of stake token, all that stuff. But in the Celestia model, you're still sovereign, you have full control, but then you're part of like an alliance essentially, where you can inherit the infrastructure and the security of this bigger sort of network, which would be Celestia.
All right. So then which types of crypto projects do you think should, go that route versus like trying to do the more traditional, like we're going to have our own security? Now that there's all these options, like what types of projects do you think should, go more like, yeah, Cosmos, Ethereum route themselves versus, being more or really anywhere along the spectrum. I don't know how many different options you think there are, but I'd be interested to hear like how developers should think about those choices.
Well, to me, I think so that there's sort of a spectrum between launching your application as a smart contract on a shared execution layer like Ethereum or Solana, and then there's being a fully custom application specific chain with its own consensus and its own blockchain completely, and then you have like the spectrum of like rollups, whether they're settled or sovereign. And I think if I were a developer, there's nothing inherently wrong with running your application as a smart contract, and in fact, there's some advantages, especially in today's world, where you get to be part of a pre-existing community with liquidity and users by launching on Ethereum or Solana out of the box. But then what could happen is that you launch your application there, you start to get traction, you get users, you get liquidity, and you build up a brand for yourself. And all of a sudden you realize like I'm hitting the constraints of the EVM or the Solana VM or just the underlying scaling properties of these monolithic blockchains. You might think, okay, maybe there's actually a real reason for me to launch my own chain. And then I'll get more scalability and I can customize certain things to make the user experience of my application more powerful. And so then you would look at the different options. And if for some reason the customization required you to have your own chain, like its own consensus, then obviously you should go that route. But for the most part, I would say like 90% or 90, even 99% of applications, I think that they get the bulk of the advantages by just being a roll up, because a lot of the customizations that they're going to want will be in the execution layer aspect, which they have full control over in the modular stack. And if they want to customize things like have an encrypted mempool or some of these more fancy things, there will also actually be modular components like that are being built by other projects in the modular stack, like sort of this new emerging layer called the shared sequencing layer. That's kind of the way I think about it. It's like you can prototype as a smart contract, and then as you mature, you're probably going to want to migrate to becoming your own chain at some point. It's just sort of like the arc, I think, of development kind of naturally.
Yeah, another important kind of aspect I wanted to mention is that if you create your own layer one chain or Cosmos chain, you usually have to like pay a massive security budget in terms of new token issuance. 10-20%, and that's a kind of like that's a very huge security cost to maintaining a proof of stake validator set. But if you deploy it as a rollup with its own token, you don't have to pay this huge inflation or kind of token issuance security budget to incentivize validators, because you don't need a whole proof of stake validator set. You can just have a few sequences will do, because the rollup already inherits the censorship resistance, ideally, of the base layer.
And also, I mean, on that point, launching, coordinating a launch of a blockchain is actually pretty difficult, because you have to. There are a lot of validators out there, and a lot of them are very sophisticated, but you still have to, gather them all together and coordinate everything and run test nets and all these things. Whereas like a roll up, you can just do out of the box. So one of the things I kind of joked about when Celestia launched is like Celestia went through the effort of launching a blockchain and issuing a proof of stake a token and all these things so that you don't have to. It's sort of like we're going through the effort so that you in the future, when you want to launch your blockchain, don't have to go through all of that work, which is very time consuming and expensive.
All right. So at this point, Celestia has partnered with Starknet to offer data availability for layer threes. You've also partnered with Polygon to integrate Celestia into their chain development kit. There's other data availability solutions that are also coming to market, like Avail, Near DA, EigenDA, et cetera. So it sort of feels like we're coming to this moment where there's going to be a number of solutions available. Potentially, they would also partner with, some of the same partners that you already have. And so, is it just going to be this future where each application or roll up or whatever will choose their own data availability layer, the same way that we see, in Web 2, there's like different companies offering software as a service for anything from, like payments to, your website or whatever. So like, is that kind of the future we're heading toward?
Yeah, so I mean, yeah, it's interesting because Celestia is the kind of like first specialized data availability layer to launch before any other competitor. So there's this kind of like huge first mover advantage. But I don't think it will boil down to costs, because the costs are extremely already low. It's like a hundredth of a cent to do a roll-up transaction on Celestia. I don't think making it a thousandth of a cent or 10,000th of a cent is kind of significantly moving the needle for a roll-up developer. So I think it will fundamentally boil down to things like, what are the security properties kind of roll-up developers want, and also more importantly, what is the developer usability going to be like? Celestia Labs and other kind of development teams have put a lot of effort into creating integrations with kind of popular roll-up frameworks like Optimism and Arbitrum. And I think the more kind of like integration Celestia has with other frameworks, the more of a kind of good developer user experience kind of evolves around it, and the more of a big community kind of like evolves around it, and so it kind of becomes this network effect in a sense that the more integrations you have, the more easy it is to kind of use it and support it as a data layer. I think that's one element of it, and the other element of it is kind of like, what are the security properties of that data layer that you want? Like different data layers have like different security properties or different trade-offs. Because Celestia has obviously data availability sampling, so it has crypto economic security, but other data layers kind of structured might be structured differently. Whereas like EigenDA, for example, resembles more of like a data availability committee, because there's no data availability sampling or data availability proofs. It's just you have to sort of like trust the EigenDA kind of validator nodes to say that this data is available, if that makes sense. Because you can't slash on-chain data availability.
Okay. So Celestia also has the TIA token, as you mentioned. Describe how that's used.
Yeah, so the TIA token has several uses. I think the first and most important use case is for the payment of transaction fees on Celestia, including the payment for blobs on Celestia. The other use is for on-chain governance. There's these on-chain kind of governance parameters on Celestia that people can vote on, including the community pool. So it's like this kind of like pool of funds that the community can vote to be spent in certain ways, pretty much like every other Cosmos chain. And then you also have, obviously, it's a proof of stake token that secures the network. You have to stake it into order to kind of like elect validators on the network. And finally, it's also kind of emerging as this kind of token that you can use to bootstrap rollups. Like if you're bootstrapping a rollup, you might not necessarily want to bootstrap a token with that rollup immediately. So kind of just like how ETH is used as a gas token for Ethereum rollups, Celestia can also be used as a kind of like token to bootstrap all rollups, whether that's as a gas token or whether that's to require some tokens to be bonded to become a sequencer in that rollup. Then Celestia, the Thea token, kind of becomes a natural choice for that.
And I'm sure you probably saw this on Twitter because I asked what I should ask you, and someone linked to this tweet. But Omid Malakan called out Celestia's token, tweeting, "Congrats to Celestia for achieving what seemingly every new L1 strives for. No, not sustainable adoption or credible neutrality, but combining a low float with a lot of hype to achieve an absurd FDV, meaning fully diluted valuation." So right now, your FTV is about $20 billion. What do you say to his criticism?
Well, I think it's pretty hard to say that Celestia has no adoption when like almost all new Ethereum rollups are using Celestia for DA. And something like 70% of all new Arbitrum Orbit chains are using Celestia for DA, and 70% of DeFi option volume is using Celestia for DA. So I think that's pretty clear adoption. But in terms of FDV or price, that's I can't really comment on that. That's not what we're kind of here for. We're here for the long term to build a kind of like a sustainable and scalable data availability layer.
Okay. And Mustafa, I have to ask you about your history before you got into crypto, because you are rather famous for having hacked the CIA when you were 16. That's a really just interesting tidbit. So can you tell us more about that and, the path that led you from that to where you are now?
Yeah, sure. So I kind of like got into computer programming from a very early age when I was like 8 or 9. And from there, I kind of like realized that programmers can make mistakes in the way that they kind of create their software. And from there, I kind of like started poking holes in like various different websites I was visiting. And that's kind of how I got into hacking. But I kind of first got into it from a kind of activist perspective when I was kind of 14, 15. When I was kind of like joined various hacker chat rooms. And this was back when the kind of hacker group Anonymous was active. And I sort of kind of got involved in various operations. Back then, they were kind of like mostly doing these denial of service attacks against companies like MasterCard and Visa as a response to, for example, them blocking donations to WikiLeaks. But then I wanted to kind of like take it a bit further to see, okay, like denial of service attacks, they're kind of interesting, but they don't do much. So I kind of decided to see, well, why not put together the most technically capable people in this group to see if you can actually like do something more substantial in terms of like uncovering wrongdoing by like hacking into kind of corporations or companies to kind of expose emails or expose data that might kind of reveal wrongdoing. And that's kind of like what we ended up doing. For example, we hacked into a company called HB Gary Federal, which was like a US military contractor. And it was revealed they were doing all kinds of things like astroturfing or creating like fake social media profiles or developing malware to kind of like spy on journalists and that kind of thing. But then eventually we ended up kind of creating this group called LulzSec, which kind of went on this 50-day hacking spree that went to do all kind of things, as you mentioned, do a denial of service attack against the CIA. That was kind of like the most kind of hype thing. Even though it technically wasn't a hack, it was like a denial of service attack kind of against the CIA. But because it's the CIA, it was kind of like very embarrassing for the CIA. I guess that's like the most high profile target. So that's the one that people kind of talk about a lot.
And then how did you make that transition over to crypto?
Yeah, I mean, because this was back in 2011, 2010. So I was kind of like already following Bitcoin back then. Because I was like before, because part of the reason I got involved into this hacking from an activist perspective is because I was interested in kind of like peer-to-peer file sharing. There was like this website, there still is this website called the Pirate Bay, which kind of like was subjected to like a lot of like governments trying to shut it down. To me, that was really interesting that you had this peer-to-peer file sharing technology called BitTorrent, and people were kind of like sharing files illegally copyright rather legally. And the US government and the entire movie industry and the music industry was trying to shut it down, but they couldn't because BitTorrent was decentralized. And to me, that was really fascinating because it was evidence that like decentralized technology was extremely powerful. So I was one kind of big, and even before Bitcoin, I was kind of like trying to think about like what else can be decentralized. Like we've managed to decentralize peer-to-peer file sharing. Like what if we decentralize the domain name system? Because like they're trying to take down the Pirate Bay domain names, for example, or trying to create like decentralized social media, for example, or decentralized chat rooms. And those were things that a lot of people, including myself, were thinking about before before Bitcoin was even created. So when Bitcoin was kind of introduced to the world, that was kind of like naturally very interesting to me, and I followed it very closely. And around 2013, when I was following it closely, I was kind of following this block size war. This was when Bitcoin reached its 1 megabyte block size limit, and there was this huge internal debate. And then there was like this fork, this Bitcoin Cash fork, and so that was like a very interesting problem to me. And I started thinking about more about how can we do base layer scaling on for blockchains. How can we scale the base layer without compromising on security and decentralization? Which is why the Bitcoin community did not want to increase the block size limit above 1 megabyte, because they feared that it would become more expensive to run nodes that verify the chain. And so that's why I became interested in kind of like base layer scalability and light nodes, and that's why I kind of pursued a PhD in it in 2016.
Interesting. Wow. I love that story. So let's talk about the future of Celestia. Obviously, we've mostly talked about it applied to EVM environments. You guys are allowing these Ethereum L2s to, be a lot cheaper, basically, and to scale. But I'm sure you're aware there's a lot of layer twos on Bitcoin actually coming out. So I had somebody ask me on Twitter if you saw Celestia becoming a data availability layer for Bitcoin rollups.
Well, it's funny because that's something that we were just discussing the other day, because we were seeing the same pattern of all these Bitcoin L2s popping up. And then we thought, well, we've built this data bridge for Ethereum called Blob. Could we actually use it on Bitcoin? And Mustafa had this idea of actually creating there's like this new like BitVM on Bitcoin. And there's a way that we could actually verify the same data commitments on Bitcoin and potentially actually provide a scalable DA for Bitcoin L2s. But I don't know, Mustafa should explain more of his vision because he's the more of the OG Bitcoiner.
Yeah, so I mean, there's a team called Chainway, I believe, that's deploying a EVM rollup on Bitcoin. It's like a ZK EVM rollup on Bitcoin, and the idea is like, well, we can easily deploy Blob to that because the Blob is basically is meant to be deployed on EVM chains because it's basically a Solidity smart contract. So you can deploy on any EVM chain. So if we just deploy Blob on this Bitcoin EVM rollup, then you can deploy Bitcoin L3s on top of this rollup that use Celestia as data availability layer. And it makes a lot of sense because Bitcoin's data availability capacity is even way more limited than Ethereum. It's like it's only got like 10-minute block times, 4 megabytes every 10 minutes. It's very limited in terms of data availability. So I think ultimately for rollups to succeed on Bitcoin, you do fundamentally need external data availability layers.
Yeah, I actually just interviewed them on my premium offering, and they talked about their new rollup, Citrea, and it was really interesting because actually another project that I had talked to was Botanics, and I guess that's more like a side chain, but I suddenly was like, oh wow, there's like a lot of activity, and there's a third I think I'm going to be talking to soon. And then, of course, this is like a perennial question, but there's always these memes about Celestia, like Solana, and Solana already has really cheap fees. They're going the monolithic route, but I don't know if you see a world where Solana would also utilize Celestia.
I think it's unlikely for Solana to utilize Celestia because I think the Solana community has made it pretty clear that they don't consider like layer twos as part of the kind of like scaling vision of Solana. There isn't really that much of a reason. Like if you're building a layer two, you probably don't want to build it on a chain where that's not what it's about, or that's not what the community kind of coalesces around. So, I mean, but it is in theory possible. Like, we could deploy a blob stream, a version of blob stream on Solana, for example. And I believe, there's like the Neon EVM, right, on Solana. So we can deploy blob stream on Neon, technically, as it is. And then Solana contracts could reference data on Celestia. But I think you were asking if Solana posts its data to Celestia or Ethereum. Because I think that's also like a common thing that Anatoly says. Well, like Solana could become like a Ethereum L2 if it just posts its data to Ethereum. That's kind of like a more long-winded discussion, I suppose.
But if that happened, then would Celestia be involved?
I mean, it could do, like, if Solana wanted to. I mean, I wouldn't see a reason for Solana if Solana wanted to become an Ethereum L2. I wouldn't see a reason for it to post its data to Celestia, because then that's an off-chain data availability from the perspective of Ethereum. Then it might as well just use Solana for data availability if it's going to be off-chain anyway from the perspective of Ethereum. So, like, in that kind of, if it was to be Ethereum L2, I think it makes sense it would have to post the data to Ethereum itself.
So then, and Nick, I feel like I asked you this before and I don't even remember what you said, but so then why is there this meme about the Celestia? I still don't understand it.
I think it stems from a few things, but at a high level, it's that this year and going to the future, there's been this like monolithic versus modular debate for a really long time, since sort of the inception of Celestia, and it's now that Celestia is launched, we actually have two protocols that are kind of embody monolithic and modular. So Solana is sort of like staunchly in the monolithic camp, and Celestia is staunchly in the modular camp. And so there's sort of like this tension, I would say, of like, these are the two protocols that represent those respective visions. And so there's sort of like this, let's see how the market reacts and actually which sort of architecture wins out in the long run. I also think so that's part of it, but there's also part of it that is about the fact that Solana and Celestia do share some common ground, in the sense of that we both believe in the abundance of block space, and we both believe in optimizing the underlying technology of blockchains to the maximum so that we can achieve the best scalability. It's just that we kind of have a philosophical difference in how we think the best way to achieve that is. And so I think it's the fact that there's a common ground, but also these differences between the two protocols that gives the significance to this Celestia meme.
Okay. So now let's just talk about what's kind of next up for Celestia. I, am seeing these announcements with these kind of business partnerships. So I imagine that that's part of it. I also, wanted to just ask about this Dimension, which allows people to easily deploy roll apps. And it recently launched, and it sort of seems like Celestia and Dimension could work together. But yeah, just you could talk about that, or just whatever else is on the short-term roadmap for Celestia.
Yeah, I mean, in the short term, from an adoption perspective, there's been all these kind of like roll-ups that have deployed on Celestia on testnet, and then now there's this coming to mainnet, and Dimension is one of them. So like Dimension is very cool because they had a testnet with like 10,000 kind of roll-ups on top of it. Like, not all of them kind of like are meaningful rollups. Maybe only a fraction of it only had the actual users applications, but it kind of like really demonstrates the point that deploying a rollup can be as easily as deploying a smart contract. So you can imagine a future where L2 Beat right now has 30 rollups, but in the future, like in a few years from now, it could have like 10,000 rollups, and it would definitely be a challenge tracking all of those. It's kind of like also various, like in the past few months, a lot of the adoption of Celestia has mainly been from Ethereum L2s. Or Ethereum rollups, not rollups, but Validiums and Optimiums. But in the next few months, we're going to expect to see a lot more like non-Ethereum or like Cosmos native kind of like rollup projects emerging. Dimension is one of them, but there's also one called the Sovereign SDK, which is kind of really cool. It's like they do Sovereign ZK rollups where you can write your application in Rust, and you can deploy a Sovereign ZK rollup on top of it. There's also like shared sequencer projects like Astria. You can deploy rollup on a shared sequencer. So that's kind of like where we stand from an adoption perspective. From a more kind of core development perspective, the Celestia community has basically launched this thing called Celestia improvement proposals, because now there's a broader kind of like core development ecosystem outside of just Celestia Labs. There's many people like there's, as I mentioned, Eiger is one of them. There's also teams like PK Labs and various Cosmos development entities, including like Informal and Strangelove. And they're kind of all participating in this. It's very similar to the Ethereum kind of like EIP process, but it's for Celestia. And there's kind of like various things kind of emerging from that. One of the more exciting things emerging from that is this idea of, because right now Celestia, as I mentioned, does not have smart contracts. So right now you cannot do a trust minimized bridge from Celestia to a rollup. Right now you have to kind of go through an intermediary third party like Hyperlane or like Axelar. But so unlike Ethereum, you can have a direct kind of like bridge between Ethereum and a rollup because it has got smart contracts. We're doing there's this proposal to have like these ZK smart accounts on Celestia, so you can create like accounts on Celestia controlled by a ZK program. And the reason why I think this is exciting is because it's very similar to Bitcoin rollups. Because right now, the Bitcoin rollup that you mentioned by the Chainway team does not have a trust minimized bridge with Bitcoin. It's like a sovereign rollup on Bitcoin. But in the future, Bitcoin will need to have a hard fork or soft fork to add a new ZK opcode to Bitcoin to allow ZK rollups to kind of bridge to Bitcoin. And so Celestia is kind of like a very similar mechanism. And to me, that's kind of like really cool because it allows you to achieve what's called kind of like functional escape velocity without having to have smart contracts on the chain. Because it allows you to basically extend the functionality of the base layer without having smart contracts. Because historically, it's been thought that the only way to extend the base layer is to have smart contracts. But with enshrining a ZK opcode and ZK rollups, I think it is going to prove that smart contracts on the base layer aren't necessary.
Interesting. Wait, but you're talking about on Bitcoin, smart contracts on the Bitcoin base layer?
No, I'm talking about like ZK rollups on Bitcoin will need a soft fork on Bitcoin to add a ZK opcode to Bitcoin. So there's like various discussion in the Bitcoin community to add ZK opcodes, so you can like verify like a ZK program on Bitcoin, and that will allow you to deploy a ZK rollup on Bitcoin. And the reason why that's cool is because it allows you to have rollups. It allows you to have rollups in Bitcoin, despite the fact that Bitcoin does not have smart contracts.
I see what you're saying. Okay. Oh, interesting. Oh, wow. Yeah, that will, I feel like, really change the game for Bitcoin, because, I feel like I've heard different sources say for a long time that Bitcoin at some point will need to implement privacy. So that will, be a big game changer. All right. Well, you guys, this has been a fascinating discussion. I've absolutely loved it. Where can people learn more about each of you and your work in Celestia?
So the best place to start is celestia.org. There's a lot of introductory material there. We have like a section, there's like a part of the website called Learn Modular, where you can learn about the basics of modular blockchains.
Nick?
Yeah, and I think another great place is to follow Celestia on Twitter. So we're at Celestia.org. I think Mustafa and I are both on Twitter too. And sharing, I'm a perpetual modular bull and trying to educate people about the benefits of modular blockchains. And so that's what you can expect from me.
Great. Well, we'll put your handles in the show notes. Thank you so much for coming on Unchained.
Thanks, Laura.
Thanks.
Thanks so much for joining us today. To learn more about Nick, Mustafa, Celestia, and modular blockchains, check out the show notes for this episode. Unchained is produced by me, Laura Shin, with help from Nelson Wong, Matt Pilchard, Wanda Ranovich, Megan Gavis, Shashank, and Margaret Correa. Thanks for listening. Unchained is now a part of the CoinDesk Podcast Network. For the latest in digital assets, check out Markets Daily, 5 days a week, with host Noel Atchison. Follow the CoinDesk Podcast Network for some of the best shows in crypto.